Sanibonani bafundi to our last segment. You are now ready to deal with the final step of the scientific method, testing the hypothesis. This is a final formality at the end of the investigation. You need to decide based on the conclusions whether to accept or reject the hypothesis. You can do this in one sentence, simply by saying that your findings lead you to accept the hypothesis or your findings show that you need to reject the hypothesis. Here are some tricky questions for you to think about. Does it matter if your hypothesis was proved incorrect and therefore you rejected the hypothesis? If your hypothesis was rejected, does it mean that your experiment was a failure? If your hypothesis was rejected, does it still mean you have done science? Now, it does not matter if the hypothesis is proved incorrect. Remember that a hypothesis is only one of a number of potential, testable, educated, possible answers. If a hypothesis is proved incorrect, it simply means that the opposite was proved correct. The experiment is certainly not a failure. You have simply proved what is not the case. This is still science. You still followed the scientific method. Now at this point, you have completed looking at each of the steps involved in the scientific method. What does a scientist do when he or she has completed an investigation according to the scientific method? Well, science is fairly meaningless if scientists do not record what they're thinking, problem-solving methods, results, and conclusions. They need to be able to share their ideas with other scientists. So they write up scientific reports. This way, other scientists can read the reports and evaluate their work and make sure that they have not made any mistakes. Scientists can also test their work with further investigations. In this way, the information that is gained through investigations can be verified or tested again, or in other ways to see if it is true. What is also a very important aspect of writing scientific reports is that the scientific information can be communicated to other people who are not scientists. Ababantu, these people can learn from the scientific report and make further decisions based on what they learn. Let's look at an example. People in government rely on scientific reports to make decisions about laws dealing with pollution, for example. If scientists have researched the effects a certain chemical has on the environment, people in government can use this information to possibly ban the chemical if it is harming the environment. So when you have done the science, your job is not finished. You have to use your planning notes and notes you made while experimenting to write up a scientific report. During the course of this year, we will meet scientific theories, such as the theory of evolution. How do theories fit into the whole scientific method? Well, once scientific data has been collected from several experiments over a period of time, all in the support of a hypothesis, then this hypothesis can be called a theory. Here is a useful set of definitions to help you. A fact is something that really exists, or something that can be confirmed by evidence which is usually observable. Facts can be proven false in the light of new evidence. A hypothesis puts forward a proposed explanation for something based on evidence or observations. It needs to still be tested by investigation or further observations before it being accepted or rejected. A theory is a confirmed hypothesis based on facts. It logically explains something. It is tested and confirmed by many scientists who have done much research. Therefore, it is a widely accepted explanation. A theory will be supported or verified by further investigations and new supporting evidence. A theory can be replaced if new contradictory evidence becomes significant. The theory of evolution, cell theory, and the central dogma, DNA makes RNA, RNA makes protein, are examples of theories in science. A scientific law is a statement based on facts that explains an action or a series of actions. Laws explains how things happen and are often expressed in mathematical terms. Laws do not describe why something happens. Theories do that. Boyle's gas laws, genetic laws such as XX equals female, XY equals male, and the laws of conservation of energy are examples of laws in science. In today's lesson, we've had an in-depth look at the scientific method and the nature of science. Now remember that many questions that you will be asked in tests and exams will expect you to draw on this knowledge. You will need to be able to apply this knowledge to various situations. I think now you've absorbed as much as you can in today's lesson, and so mona na ga khona ku lesson yethu elandelelayo.